Good evening, all of you. Welcome to ACE Engineering Academy online, ACE Online. It is privilege. It is it is privilege to introduce myself, K. Hanumantha Rao, having nearly 20 years teaching experience. Out of that, 15 years for taking GATE and ESC classes. I have been associated with the ACE Engineering Academy more than 12 years for mentoring various students, those who are preparing for the competitive examinations like GATE, ESC, and various public sector units like GENCO, TRANSCO for various states. Guys, now I am here to discuss about that what is the role of the main important subject under electrical stream, which is electrical circuits for PSUs, public sector units. Now we are having the various states. What are the public sector units we are having under electrical, AE, AEE and JE jobs? Let me consider that. Suppose if you take in Telangana state here, Telangana TS GENCO and TS TRANSCO, like that. In AP also, AP GENCO and AP TRANSCO, like that. In Karnataka, KPTCL, Karnataka Power Transmission Corporation Limited. In Maharashtra also, you can see that in Maharashtra we are having Maharashtra State Power GENCO Corporation Limited. Like this, we are having so many public sectors under generation or electrical corporations. Under that, if you want to target that job, either assistant engineer or assistant executive engineers or junior engineers, if you want to target that, guys, definitely you should adopt three things for each and every examination, competitive examinations, public sector units. Now let me explain that those three PCs, not personal computers. I can say that the three PCs are: first P and first C is presence. Guys, once you enroll the course in ACE Engineering Academy online, first you have to present in the class. That is very important. You need to watch the video completely, or if it is physical class, you should present the class. That is very important. You should not absent. Once you present the class, you should concentrate on what concept faculty is going to give that. You need to concentrate on the concept. The next P, I can say that performance. Simply sitting, you will not get any concept. You should perform. This is very important. By performing, what you will get it? Definitely you will get confidence on that particular area, on that particular concept. Is it right? Now once you get this performance with the confidence, definitely you will get it, the perfection of that particular concept that leads command on that particular subject. Command on that particular subject. These three pieces are very, very important here for any competitive examination. For any competitive examination, these three pieces are very, very important. Is it right? Now let me take that here. What is the role of electrical circuits for public sector units? For public sector units. Let me consider that for each and every examination, this electrical circuit subject is the main subject here. This is very, very important, or you can say that this is the prerequisite for common subjects as well as core subjects. Let me take that here. The prerequisite for most of the subjects, out of that, what are the common subjects? The common subjects are control systems. Compulsory is required, KVL, KCL, and the next one is analog electronics. This is very important here. Under analog electronics, Kirchhoff laws, we are applying CDR, VDR, current division rule, voltage division rule, as well as the most important topic under electrical circuits, which is two-port network parameters. Under two-port network parameters, we are going to discuss under analog circuits. If you want to analyze the network, we should consider that one of the most important parameters, which are hybrid parameters. Using the hybrid parameters, we are able to design that hybrid model of the BJT, which may be either C or CB or CC configuration for analysis of amplifier or transistor. Is it right? Now, the next one is electrical and electronics measurements. This is very important here. Electrical electronics measurements compulsory, we need to have the prerequisite, nothing but the basics under electrical circuit basics. Is it right? Now, what are the core subjects? If you take the core subjects, this is the prerequisite for the core subjects also. What are the core subjects? Usually we are identifying under electrical engineering, the core subjects are electrical machines. This is very important here. Without the basics or without the basic concepts, we cannot go through these all the numericals under electrical machines. Compulsory, Kirchhoff laws, CDR, VDR, nodal analysis, mesh analysis, these are very important for this one. And while coming to that, the power systems, under power systems also, compulsory, these basics are very important. Especially you can say that under two-port network parameters, applications of two-port network parameters for the transmission lines, right? Based on that, we are able to study that, how the parameters, ABCD parameters are related with the transmission parameters, and more topics are related with that basics which you are going to be learned under electrical circuits. Is it right? Now, let me take that the next power electronics. This is very important here. Power electronics subject, usually you may feel it is very difficult. But once you enroll with that ACE Engineering Academy, either offline or online, definitely you should feel very much comfortable. Why? Because first of all, you will know that what is the basic difference between the power electronics and normal electronics. Power electronics means the electronics where we are using that with the power devices. What are the power devices? What is the main difference which we have taken? The analysis, if you take that under characteristics, usually we are considering the characteristics of any electronic circuit. You need to be analyzed in three regions. Number one is active region and saturation region and cutoff region. Usually, normally power electronics or normal electronic circuits, you are dealing under active region. While coming to that power electronics, we are dealing that power electronic devices under saturation or cutoff region. Nothing but we are treating those or switches. Is it right? That's why very important topic in this one we are going to discuss under transient circuit analysis, how the switching action is to be performed. That we are going to discuss under transient circuit analysis. This is the prerequisite, whatever the electrical subject, electrical circuit subject is the prerequisite for core as well as common subjects. Now, let me take that what is the syllabus, overall syllabus, or you can say that the common syllabus for all these public sector units which I have mentioned earlier, which are related with that Telangana state or AP state or Karnataka state or Maharashtra state. What is the common syllabus under this subject? I am dealing with that network theory or electrical circuits. That's why the syllabus under electrical circuits for these all the state public sector units. Let me take the syllabus of electrical circuits. The syllabus of electrical circuits for PSUs, for AE, assistant engineer, assistant executive engineers and junior engineers, right. Let me take that here, the topics which we can take it, the basics. First, you should be thoroughly get the confidence under basics. What are the topics under basics? Now, the contents under basics, classification of network elements, here linear, non-linear, active, passive, bilateral, unilateral. Usually we are defining based on the characteristics and behavior and properties, we can classify into 5 pairs. linear, non-linear, active, passive, bilateral, unilateral, right, lumped, distributed, and time variant and time invariant. These we are going to discuss under classification of network elements. And Ohm's law, this is very important here. Ohm's law, wherever you go, definitely you should follow this. And while coming to that, this electrical circuits or network theory, the Ohm's law, we should know that what is the Ohm's law and what are the limitations of the Ohm's law. This is also very important. Under what conditions we are going to be analyze the given network, that is also important. That we are going to discuss under Ohm's law. And here the Kirchhoff laws. This is very important. Without this, you cannot take any circuit solution. Is it right? Now, while coming to that, equivalent circuits with respect to passive RLC elements. Now, guys, once you get these the basics, which are Ohm's law, Kirchhoff laws, equivalent circuits with respect to passive elements, this is a compulsory one mark or one question you will get it. In any PSUs, compulsory questions, equivalent circuits or equivalent, L equivalent, C equivalent, compulsory question here with respect to passive elements. And we will discuss active element also. The next one here, this is the active elements and nodal analysis, mesh analysis. Compulsory question you will get it. And source transformation technique here. Under source transformation technique, this is the one of the simplification technique which you need to be learned for simplification of any given electrical circuits. You may get a doubt, sir, why you are going for that? We are having these methods, simplification techniques. Why you go for the source transformation technique? Usually, if the network is having multiple sources, we should go for this one, source transformation technique. Without taking calculation, without putting pen, we are able to get it. That is the advantage of this one, right? And this source transformation should be applicable only the practical sources. It is not applicable for the ideal sources. And the next one we will discuss, the next topic is we will discuss the transient circuit analysis. Guys, this is very, very important topic, interesting topic also. Once you see that, whatever the classes we are providing online, if you see this, very, very interesting, you will get it here. Definitely you will enter into the other world while you are learning this topic. You need not go for any preparation in the examination, right? Whatever the question is given directly, by reading that you are able to identify which is the correct option, believe me. And here under transient circuit analysis, classification of transients. First of all, how the transients. Transient response, I think you are aware of that. The response which is varying with respect to t or with respect to time, that response is nothing but the transient response. If it is not varying with respect to time, nothing but. If it is having constant frequency, then that is nothing but the steady state response. Either DC or AC, 50 Hertz, if it is operating, that will come under steady state analysis, right? And the transients, you will get it by applying that the switching action, nothing but sudden changes. If you provide the sudden changes, then after sudden changes, whatever the response you are getting, that response may not be the single response. It is a combination of transient and steady state, subject to the condition that network should have energy storage elements. This is very important. Two conditions should be satisfied if you want to analyze the network under transient circuit analysis. Number one is switching action, nothing but sudden changes should be provided from the excitation. Second thing is the network should contain at least one energy storage element, either inductor or capacitor or both. Then only we can study this transient circuit analysis. Now, while coming to the classification, based on that excitation, you can take the DC transients and AC transients. But the effect of the transients are more for DC excitation. That's why we need to consider that the DC transients, under this, the subclassification you can take it under DC transients based on the memory elements, which are energy storage elements. I can take that first order and second order. And also, under first order, we are going to take that subdivision, that is the source free circuits, which are having that source free circuits means what? Physical source will not be there. but internally there is energized element is present, which may be either inductor with initial current, capacitor with initial voltage. You are aware of that, why inductor is initial current, why not initial voltage? The energy in the inductor is the form of current. Why it is? The flux produced by the magnetic field is directly proportional to current which is coming from the source. Like that, the capacitor charge acquired by the capacitor is directly proportional to applied voltage across the capacitor, two parallel plates. That's why the energies can be considered, can be referred in terms of the current for inductor and voltage for the capacitor. Next one is here with the source circuit. Sometimes sources are there. Under that instant also you will get the transient responses after sudden changes. Now let me take that the second order. Under second order circuits, the questions you may concentrate especially under PSUs here. This is very important. Under PSUs, circuits with conditions at t equal to 0 plus and at t equal to infinity. This is the very important condition. These two instants I have given that. First one is t equal to 0 plus and t equal to infinity. At these two instants, you are having the circuit nature is only resistance. The circuit nature is only resistance. That's why the response is also finite response you are getting. The response is also finite response you are getting. Questions, if you see that previous examination questions under transient circuit analysis, more questions you can expect on this. More questions at these conditions. And one more, if you want to get it, that responses after t equal to 0, nothing but the transient response nature, how it is, whether it is decaying or rising, then definitely we should go for that analysis with the Laplace. And not only that guys, whenever if the excitation is given, impulse excitation or impulse response if you are getting, then that will deal with the Laplace. Usually how you identify that? When the network is having impulse response or impulse excitation, I can say that at t equal to 0 condition, if you develop the network, at that instant, that network should violate either KCL or KVL, definitely. Under that instant, we should consider that the network is affected with impulse, response or excitation. Under that instant, analysis will be by using Laplace transform analysis, right? This is about the transient circuit analysis, right? And the next one is very important, AC circuit analysis. First we have taken the DC analysis, next we have taken the transient, next we need to consider the steady state part. AC circuit analysis means excitation should be having with a finite frequency. That finite frequency means you know that any sinusoidal waveform should have a finite frequency. First of all, in this we are going to discuss about the generation of sinusoidal waveform. How the generation? First of all, so many alternating quantities we are having, either sine or non-sinusoidal. Why we are considering only the sinusoidal? What is the importance of the sinusoidal? Because the available energy is always in the form of the sinusoidal. Suppose as per the customer requirement, if you want to take that the non-sinusoidal as input, definitely we should convert from the sinusoidal into non-sinusoidal. By using the electronic devices, we can develop, we can design that output as the non-sinusoidal, then that we can utilize where you want to develop the network. Is that right? And under sinusoidal here, we are having some of the finite values for circuit analysis. What are those values? We can say that average value or MS value, form factor and peak factor. These values compulsory we should go for that finite values. You may get it out, sir, finite values why we are considering. Guys, if you take that any network, if I am applying the sinusoidal waveform, you cannot say that with analysis V of t is equal to Vm sin theta. You can say that we are applying. But for analysis of the network, when the load circuit is at, it may be either resistive or inductive or capacitive, which may have some phase displacement. Under that instant, we should go for circuit analysis with the finite values. If you want to convey that finite value, I need to go for that average or RMS, form factor and peak factor. Using these two values, we are going to define form factor and peak factor. Right? The importance of the form factor, peak factor, we will discuss. Right? What is the importance of that form factor and peak factor? Right? In transformer, by using the average, if you want to get that RMS, here you may get a doubt why RMS. Circuit values are always RMS values. Whatever the supply we are getting 230 volts is the RMS value. It is not the maximum value. It is not the average value. It is the RMS values. Circuit values are always RMS values, which are finite values, right? Now, in the examination, especially in PSUs, he will provide that, he will ask the question related with the non-sinusoidal, triangular waveform, square waveform, trapezoidal waveform, sawtooth waveform. What is the average value? What is the RMS value? How much the power dissipated across the resistor? These type of questions we may expect on average RMS values for different alternating quantities, right? Now, while taking that for the AC excitation, how the RL, RC, RLC series and parallel circuits are affecting. What are the voltages, currents, power, power factor? These we are going to discuss under this RL, RC, RLC series and parallel circuits, right? Now, while coming to that here, the instantaneous power. Guys, till now definitely you will get 2 marks here, because this is the more weightage in electrical circuit. This is a very important topic, AC circuit analysis. Now, instantaneous power, power factor and power triangle. What is the instantaneous power? Usually if you take that instantaneous voltage, if you apply some voltage, instantaneous voltage across any load circuit, the obtained current is also instantaneous current. Suppose if you take that V of t is equal to Vm sin omega t, then definitely across a inductive or capacitive any load, you are going to get that I of t is equal to Im sin omega t plus phase displacement or phase angle or load angle, you can take it. To take that these two instantaneous values or instantaneous equations, we can develop or we can define that instantaneous power. Guys, this is very simple. At any time, if you are going to get that particular value, at any time the finite value of that particular response, it may be either current, voltage or power. That is nothing but the instantaneous value, right? Now, using that instantaneous values, we are able to define for AC circuit analysis active power, reactive power, right? And using that active and reactive power which are existing in the network, we can define that a combination of these active and reactive power, which is called apparent power or resultant power, which is also called complex power. That is not existing. That can be defined by using the two existing powers when the network is either lagging or leading. Now, while coming to this power factor and power triangle, using these 3 powers we can construct that power triangle. Guys, up to this you should get definitely 2 marks. Previous transients also you will get 2 marks. And while coming to that, the next one, resonance, bandwidth and the quality factor. And the next one is current locus diagram. Here up to this again you will get at least 1 or 2 marks. 1 or 2 marks. Resonance, bandwidth and quality factor. This is very important topic here. This is very important topic. And current locus diagrams also. Sometimes you may or may not get it. But resonance, bandwidth and the quality factor definitely you will get 1 mark. This is about that AC circuit analysis. Now, once you are perfect with that DC, AC and combination of nothing but transient analysis or transient response and steady state response. These are the main topics which you have to take it. Once you know this, then definitely we should go for that simplification techniques. In our electrical circuits, we are having some simplification techniques here. Already we have seen that source transformation technique. Out of that, when the network is complicated, then definitely we should go for some alternate techniques. Suppose if the network is a big network, complicated network is there, using nodal analysis, mesh analysis, I can get across each and every element response, but I don't need that. In the complicated network, I want a specified branch response. It might be either here current or voltage or power. Under that instant, if you use that nodal and mesh analysis, it will take so much time. For that, we are having some alternate techniques which are circuit theorems. That is very important. Here, compulsory question you will get it under circuit theorems. Under this, we need to take that. What is the necessity of the circuit theorems? For what type of networks we can take it? Under the circuit theorems, we are having, according to the syllabus, as per the PSUs, which are for various states, either Telangana, AP, or Maharashtra and Karnataka. If we take that, 4 theorems are their main theorems, and next 3 theorems which are having the applications. Now the 4 theorems are, first one is the superposition theorem. You know that superposition theorem, when we need to go for superposition theorem, what is the compulsory condition for superposition theorem? The network should have at least 2 sources, 2 or more sources should be present. Then only we can take the for simplification of the network by using the superposition theorem, right? And also one more thing I would like to raise here, superposition theorem, when we need to go for that, sometimes if 2 or more sources are there, instead of superposition theorem, I can go for the other theorems also. But while coming to that, if the network is operating with the 2 or more sources with multiple frequencies, this is very important here. Once you identify the network is operating with the multiple frequencies, for example, DC and AC. If the network is operating with the DC and AC, when the network elements are present, energy storage elements, inductor, capacitors and resistors are there. If you want to get the response, we cannot take the normal analysis. Compulsory. Why? Because if DC is there, AC is there. DC is having 0 frequency, AC is having a finite frequency. Now how I could take that, how I need to consider that effect of inductance or effect of capacitance. Usually effect of inductance means ZL is equal to J omega L. That omega, which omega we have to consider? DC is 0, AC is some finite. It may be 50 Hz. Which one we have to consider? Under that instant, we should consider definitely superposition theorem. Otherwise, there is no alternate technique. Compulsory, we should go for the superposition theorem. No doubt in that. We cannot take that alternate solution for that. Right? Because superposition theorem analysis is, or simplification is, always with one source. At a time, only one source, we should go for that. Right? That's why superposition theorem is that one. Now, while coming to that, the next one is Thevenin's and Norton's theorems. These two are mutual friends. Nothing but what? If you know Thevenin's, you can get Norton's. If you know Norton's, you can get Thevenin's. By using what? Source transformation technique. This one is also these Thevenin's and Norton's theorems will play the vital role in circuit theorems topic here. Why? Because any network is given, I am able to replace that entire network as a simple circuit here. Under Thevenin's and Norton's across the load circuit, even though if it is given a complicated network, I can take that across that one branch or load circuit, entire effect can be replaced with a simple network under Thevenin's practical voltage source, under Norton's practical current source. It's a very simple one, right? Now, these 3 theorems are very important. And one more compulsory question you will get it here. This one is what? Maximum power transfer theorem. Maximum power transfer theorem is, this is the application of the Thevenin's theorem here. This is the application of Thevenin's theorem. We can take it. This is the application of Thevenin's theorem. If you want to take that from here to here, source transformation, you can take it. But while coming to this, definitely we should go for that Maximum power transfer theorem means two conditions we have to verify. First, load is variable or not. If load is variable, definitely we can apply this maximum power transfer theorem. If load is not variable, we cannot apply. Right? Then on the time we should go for the other condition. We should go for the other condition. Maximum power transfer theorem cannot be applicable if the load is fixed. Now, second condition is very important. Across the load circuit, where you want to get the maximum power across the load circuit, except that across that load circuit entire network, whether it is Thevenin's equivalent or not. Why Thevenin's equivalent or not? If you take that Thevenin's equivalent, we are having direct answers or direct cases we are having. That is, these two conditions should be verified under maximum power transfer theorem. Is it right? Thevenin's theorem, and here the Thevenin's theorem is the application. Here maximum power transfer theorem is the application of the Thevenin's theorem. Right? And the next one is up to this, these four theorems are very important. Compulsory question you will get it here, no doubt in that. The next one is reciprocity theorem. This is the application, or which we can take it whether the network is reciprocal or not, non-reciprocal or reciprocal. Now, how you have to define that? And the next one is the Milliman's theorem. This is very important here. This theorem is also called parallel generator theorem, right? Parallel generator theorem. All the, suppose n generators are connected in parallel, then resultant one we can take it. This is the parallel generator theorem. This is the parallel generator theorem. And intelligence theorem. That is the, just like a KCL, KVL. This is related with Kirchhoff laws. This is related with the Kirchhoff laws, KCL and KVL. How we are considering that KCL and KVL? The same way we can take it. Nothing but what? If any network is satisfying KCL, KVL, then only we will follow. We can take the analysis, except the transient, that is different here. Under transients, violation of KVL, KCL means we have a chance, or we can analyze the network by using the, here, that is the special functions. We can go with that Laplace. But here, normal analysis, if you want to take it, each and every network should be satisfy KCL, KVL. There in the transients, we are discussing the response in two ways. Number one is transient as well as steady state. There is a change, response is changing with respect to t. If it is operating a constant frequency, then definitely those circuits should be satisfied Kirchhoff laws as well as intelligence theorem. Right? These are the under circuit theorems. These four topics are very important. Minimum 8 to 10 questions you will get these four topics. No doubt. Any PSUs. Any PSUs. If you see the history of that, any PSUs, compulsory 8 to 10 marks you will get it. Right? Believe me. And the next one is here, we are going to take that, the next topic is the magnetic circuit. In this 1 mark compulsory here. Under this, the analogy between that electrical network and the magnetic network. Nothing but what? Electrical network and magnetic circuits means what? Electrical circuit means, first of all, circuit is nothing but what? Closed path formed by the electrical elements. Magnetic circuit means what? Closed path formed by the magnetic elements. What are the magnetic elements? From the electrical elements or from the electrical properties, you can define that magnetic properties. Why? Because magnetic circuit properties are quite similar to the electrical circuit properties. That's why we can define from that. Next one, sometimes recently last 4 or 5 years, if we take that state board examinations in these 4 states, we can identify the questions related with the magnetic materials. That also we are going to provide. And coupling circuits. In this coupling circuit, electrical coupling circuits, magnetic coupling circuits are there. This we are going to discuss, and series magnetic circuits and parallel magnetic circuits. And main important thing is, this is very important, compulsory question you will get it on this. Dot convention. Magnetic circuits means usually you can expect the question on dot convention, which is related with the mutual inductance, And sometimes you may provide that the concept of ideal transformer circuit model. This is very important. This concept is very important for transformers, electrical machines. In electrical machines, the equivalent circuits, how you are converting the equivalent circuits for circuit analysis. This is about the magnetic circuits. And the next topic for the PSUs under electrical circuit subject, two-port network parameters. You know that port is nothing but what? Port is a pair of terminals. Two-port means 4 terminals are there. 2 terminals are related with input port, 2 terminals are related with output port. Using this input and output port, we are going to define some variables. Suppose if you take input port, 2 variables, voltage and current, V1 and I1, output V2 and I2. Based on these 4 variables, we are able to define that the parameters for that electrical circuit or 2-port network for analysis in the form of 2-port network. What are the 2-port network parameters? Here, if n variables, if you take it, not only 2-port, 3-port, 4-port, 5-port, n variables, if you are able to define, NC2 parameters can be defined. Here, 4 variables for the 2-port network, 4C2, 6 type of parameters we can define. What are the 6 type of parameters can be defined? Now, under these 6 type of parameters, which are Z parameters, Y parameters, ABCD parameters, inverse ABCD parameters, hybrid parameters and inverse hybrid parameters. These are the 6 type of parameters can be defined according to the variable 4C2, where 4 is equal to, which we can take it. What are those 4? Here V1, I1, V2 and I2, which are the variables related with port 1, port 2, right? And for all these 6 type of parameters which we are considering for analysis of the any given electrical or electronic circuits, we should define that condition for symmetry and condition for reciprocity. Questions are asking, especially questions are asking in public sector units like GENCO and TRANSCO. Compulsory you will get this condition for symmetry and condition for reciprocity for all these 6 type of parameters. Compulsory question you will get it here, no doubt, believe me. And next, series and parallel connection of this one. Series and parallel connection of 2-port network parameters, which we can take it. Usually series connection for Z parameters, parallel connection Y parameters can be added. Now, while coming to that, the next one is here. Here, this is about the 2-port network parameters. Next one is one more topic is there, which is very important topic, compulsory question in this one for PSUs, public sector, it's graph theory here. The graph theory, if you take the graph theory, in the graph theory, here we will not identify any inductor, resistor, capacitor, voltage source, current source. Sir, why we are discussing this? Suppose if the network is a big network, right, a big network which may have number of closed paths are more than 10, 20, 30, 40, 100 are there. We cannot take manually the electrical properties. Under that instant, we can go for that geometrical properties. To analyze the geometrical properties, we should consider that for any network, that is nothing but, that concept is nothing but network topology or graph theory. Under this graph theory, we are going to be discussed about that connected graph and oriented graph. Usually, all the passive elements can be replaced by their internal, by all the passive elements by a line segment, and active elements can be replaced by their internal resistance at ideal conditions. Nothing but what? While you are converting from electrical circuit into the geometrical circuit or geometrical network, all the passive element, resistor means one line, inductor means one line, capacitor means one line, voltage source means what? Short circuit, current source means open circuit. But guys, remember, under current source, the assumption is there. You should consider that current source is always be practical. Why? Because suppose ideal voltage source is there. If you make that as a open circuit, then there is no physical connection. But actually, electrically, in the original network, there is a connection. That's why current source should be considered. Even though ideal is given, we have to be considered that as a practical, nothing but take one parallel resistor, take the connection in the equivalent geometrical network from the electrical circuit. That is not, that case you cannot identify under voltage source. Even though ideal voltage source, we are going to replace that as a short circuit, equivalent value we are getting as a element. That is why here the geometrical network, that geometrical network from the electrical network is nothing but the graph of the network. If that graph is having directions, that graph is nothing but the directed graph or oriented graph. Usually geometrical analysis can be done by the directed graph only, right. Now these geometrical properties can be discussed in three matrices. One is incident matrix, tie set matrix, cut set matrix. This will be give the directions and this will be give that here mesh analysis, tie set matrix, and this will give the nodal analysis, right. Cut set matrix will give the nodal analysis. And while coming to this, all these we are going to be discussed under graph theory. Compulsory question you will get it here. Number of links, trees, these are all direct formulas are there. You need not go for any preparation for this one. Whatever the classroom practice, that is more than enough. Practice is required for first four, right. Now the next one is one of the most important topic which can be used as a prerequisite under three-phase circuit, under power systems as well as electrical machines, that is the three-phase circuits under polyphase circuits. We are considering under three-phase circuits the first topic as importance of the three-phase circuits. Why out of all polyphase we are going for three-phase? First of all, why we are going for the polyphase? To get the more level. I need for domestic purpose, okay. If you want to make or any product in the industrial side, if you want to take that single phase is not sufficient. We need to improve that, or we need to increase the level of the voltage. Then definitely I need to take that number of more phases. Under that, what is the three phase? What is the significance of three phase circuits, or what is the importance of the three phase circuits? What are the advantages of the three phase circuits over all the other phases? That we are going to discuss under importance of the three phase circuits. Next one is under three phase we need to discuss about that star delta connected supply systems and classification of three phase circuits based on the load. Based on the load we can take it balanced and unbalanced systems. Under unbalanced and balanced, if you want to take that the power measurements, here power measurements of three phase power can be done by in three methods. Number one is 1 wattmeter method, which is only valid for the balanced circuits. 2 wattmeter method, which is valid for both balanced or unbalanced. And while coming to that 3 wattmeter method, 3 wattmeter method we should consider only for three phase 4 wire supply systems only. Because if you want to connect that 3 wattmeters, compulsory neutral wire should exist. Nothing but the supply system should be 3 phase 4 wire supply system. That everything you will discuss under three phase circuits, right. This is about the syllabus which we are going to take under electrical circuit subject for any public sector units in GENCO and TRANSCO for these 4 states, Telangana, AP and KPTCL, as well as here what it is Maharashtra, right. And while coming to this one here, what are the reference books which we need to refer? Guys, I can say that once you enroll with that ACE Engineering Academy, either online or offline, definitely you will get it. Definitely you will get the perfection in each and every concept, believe me. Because the reference books means, I can say that reference books 10 books, but that is not your job. If you want to do that, it will take so much time. That is not your job. That is our job. We have already done whatever that important area for this particular examination, for these PSUs, we can give that. We can give the lecture on that. We know that as per the previous papers, I can say that for this particular examination, under this electrical circuit, this topic is very important. Under these topics, what concept we need to learn and how the marks are getting and how many examples you need to practice, everything we will do that. But even though if you want to reference books, I would like to suggest only one book here, which is very good book. I can say that here, this is the Fundamentals of Electrical Circuits by Alexander and Sadek. This is very good book here. Why I am saying this is the any edition you can take it, recent edition or old edition, any edition. Why I am suggesting this? If you take this book, each and every concept, first he will provide for that particular concept the history of that and what is the definition of that. And next one, he will provide some worked out examples. Next one, lot of exercise questions are there. And not only that, in addition, he is providing the applications of that particular concept. This is the here very important for this one. That's why this is the content which we can get it under this book. That's why I am suggesting this, right? If you want to take that any concept as per the syllabus given by that particular PSU, you can refer this one, and if you want to practice more examples or more numericals, definitely we need to go for sham outlines. These are the two books I can suggest you. Okay. Now, in this session, I would like to take one topic. Under that, I want to summarize some of the points under the topics, and I want to get some of the answers from you. How the public sector unit questions I have prepared, and I will give you. You need to give the answer, and I will give the solution also here. Let me consider that out of all these topics, more weightage in electrical circuits, which is AC circuit analysis here. Now, let me consider that AC circuit analysis. Under AC circuit analysis, this is the topic today I am going to discuss. First, I will summarize that what are the main important points under this AC circuit analysis. And later, I will give that some questions, some examples. Those examples are given in the previous PSUs, public sector units, various public sector units. Let us take that the summary of AC circuit analysis. I am not going here each and everything. It will take so much time. We are having 1 hour. That's why here I want to give that some highlights of this AC circuit analysis. And the main thing is questions, how the model questions you are going to get in the examinations. Right? Now, let me consider that the summary of AC circuit analysis. The first one, I can take it here, how the behavior of the resistor, inductor, capacitors, pure elements with respect to voltage and currents. See this one. The pure elements, how they are reacting with this, the behavior of pure RLC. Now, you know that resistor, voltage and currents are in phase, and inductor, current lags voltage by an angle 90, or you have to remember one more thing here, that is what voltage leads here. This is very important. V leads I when I is reference. This is also very important. All are remembering that only lag. Sometimes current may be reference. Under that instant for inductor, voltage is going to be leads. Right? Like that capacitor. Leads means capacitor, lags means inductor. Don't think like that. Which lead, which lag. You should get the confirmation from that given question. That is very important. Right. Now, the phase angle here 0 degrees because both are in phase. And while coming to that, the phase angle under pure inductor is 90 degrees. Here also 90 degrees. You know that whether lead, lag, that is depending upon that applied voltage and resultant current. Usually voltage as reference. That's why current behavior we are studying here. If voltage is reference, current lags. If voltage is reference, current leads here. Right? But sometimes it may be here, it may be reverse. That's why don't remember that lead, lag, lead. Which is lagging? That is very important. With respect to what? You should get the clarity regarding that. Now, impedance across resistance is or ZL is across pure inductor is j omega L and pure capacitor 1 by j omega C. And regarding the power factor, this is very important. Some of the questions you may get it directly related with the power factor, your power factor UPF and 0 power factor, 0 power factor. for pure inductor and pure capacitor. Guys, pure inductor, pure capacitor, not available practically, but you can analyze by assuming that as a pure element. Is it right? Pure resistor is available. Resistive load means pure resistor, right? Now let me consider that the next one is the combination. Suppose if we take the combination RL, RC, RLC. This is about that the voltage relation. This is very important here. Voltage relation is the not algebraic relation. It is the vector relation. Why vector relation? Because voltage and current behavior across resistor inductor is not similar. Just now we have seen. Once you are adding that, you cannot add directly here. There is a phase displacement. That is why this is Vs is equal to under root Vr square plus Vl square. Nothing but what 90 degrees phase shift. This relation is valid. Remember this. This relation always valid. Both the vectors are displaced from each other is equal to what? 90 degrees. Remember that. Without 90 degrees, this is not valid. Why? Because according to the Pythagoras theorem, right? Once you ensure that both are having displacement or both are phase displacement is 90 degrees. Like that capacitor also here in RLC series circuit VL minus VC square, not VC square, this is I can say that VL minus VC whole square, VL minus VC whole square. Why VL minus VC whole square? That you know that the both vectors are displaced from each other is equal to 180 degrees, right? And while coming to that impedance also you have to remember that R plus JXL, this is R minus JXL and R plus J times of XL minus XC, and XL by R tan inverse phase angle, XC by R, actually minus XC by R, you may get it, magnitude here I have given, and XL minus XC by R. I lags V, I leads V, and based on XL and XC values, I and V, how they are behaving, right? Now while coming to that, the power factor, this is very important here. Power factor for RL series circuit VR by Vs, VR by Vs, here VR by Vs, here also VR by Vs. For all the RL, RC, RLC series circuits, formula is same, but values are different. How? Because here this is what? How they come? Vs under root VR square VL square, Vs under root VR square Vc square, V, this is also Vs. Vs is what? Under root Vr square plus Vl minus Vc whole square, because Vl leads, that is why you will get it Vl minus Vc. Is it right? The same way I can define for parallel circuits. The same way I can define for parallel circuits. Right? Here currents. In series circuit, current is same, voltage division. In parallel circuit, voltage is same, current division. The same way we can take it. G minus JBC, IR square plus IL square. Now IR square plus IC square. IC minus IL. IC minus IL whole square, that is very important. Rest of the thing all are same. Here plus only, because here we are getting B. B is what? Susceptance. Inverse of reactance is called susceptance. And IR by IS all are. There VR by Vs. How we have taken here IR by IS. Got it? Now this is about the here series and parallel circuits. Okay? This is about that series and parallel circuit. Now let me consider that the next one is power factor, power triangle, power factor and power triangle. Now let me consider that instantaneous power. I have given instantaneous power. This power we can define in two. Number one is active power, reactive power. This is due to on resistance, this is due to on reactance. It can be XL minus XC or XL or XC. It should be in the function of what it is? It is the function of what? Omega t. Now here average power is the average of the power waveform, which in turn is product of voltage and current waveform, but this exists only for the resistive of the network, resistive part of the network. Hence average power means active power or real power in watts, which can be determined from any component or network only. This is the output power. Average power means it is what? Output power here. Simply you can say that. Total power, how much power we are getting from that. This power we can take it, active power is real power, power displayed by the network, true power, and here power due to on the resistance, power dissipated by the network. All these are real power. All these powers are related only with the resistance, which is the output power. That power is called active power, which is here Vi cos phi, where V and I are RMS values. Resistance is the important part for the interconversion of the energy. Generally, sources are rated in VA and load power is in kilowatts. You know that sources. And resistance is the real power. Inductance and capacitance is the reactive power, power due to on. This is in terms of watts, this is in terms of VAR, volt, ampere, reactive. And while coming to that combination of active and reactive power is called apparent power, there is a possibility which we can define that here, positive and negative. If it is positive imaginary part is there, that is the absorbing power due to on the inductive nature. If it is negative power is there, remember that. Negative power means that is the generating power due to the capacitance. Like inverter, you can take the generating power which we can utilize when the sources are absent. When the sources are absent, this is the lagging VAR we are calling. This is the leading VAR we are calling. Right? Remember that. And here, as the power system, the power loss due to the reactive power is almost lagging VAR only. So net Q reduces, then terminal voltage at the load side is also reduces. This one we have to take it. Here P is equal to S cos phi or VI cos phi watts, and if power factor is poor, then active power delivered to the load also reduces. Power factor is related with what? Active power. And power factor says how much of the apparent power is utilized, utilization of the power. The power factor is high, then active power delivered is also high. So always high power factor is required. That's why usually loads are what loads here? Existing loads are what loads? Inductive loads. Capacitive loads are not there. But capacitor which we can use to improve the power factor of the systems. As a customer, if I take any network, any load, if I want to utilize that, I need to get the maximum output. Maximum output means due to on the resistance. Due to on the resistance means power factor should be high. If the low power factor support existing, then we need to make that as a high power factor. How you make that as a high power factor? By taking the capacitor. That's why capacitor is nothing but a VAR compensator. VAR, volt, ampere, reactive. We can improve the power factor of the system. With that we can get the output. Output will be increased. Power factor is increased. Since the output is nothing but active power, VA cos phi is increasing, P is increasing, right? Now the next one which we can take it, a very important concept under summary of AC circuit analysis, resonance here. This is very important. Resonance can be defined in 4 ways. Let me take that. In 4 ways you can define. First one is, here it is the network should be pure resistive, assumption, and the phase angle is 0 and the power factor is unity and voltage and currents are in phase. According to the given question, any one you can consider. Sometimes you may provide that phase angle, sometimes you may provide that unity power factor, sometimes you may provide that voltage, applied voltage and resultant current, both are in phase. Is it right? And classification of resonance. Resonance also we can take it based on the circuit when both the energy storage elements are present. We can take it into 2 types. Number 1 is series resonance, number 2 is parallel resonance. This parallel resonance, series resonance is circuits are nothing but acceptor circuits here. While coming to that parallel resonance, is called anti-resonance. Parallel resonance is called anti-resonance. Why it is anti-resonance? Because resonance means we should get the maximum response. We can take the maximum current, RLC series circuit. But in parallel circuit, we are getting that minimum current, I is minimum current. That's why we can take it, these are the anti-resonance. These circuits are called acceptor circuits. These circuits are called resistor circuits. Under parallel, we can take it, the combinations all are parallel. RL and C are in parallel. Usually this will be referred as tank circuit, and RL and RC are in parallel. RL and RC are in parallel. Now, some of the factors which we need to take it under resonance, series resonance. If we take the series resonance, omega naught is equal to 1 by root LC and maximum current is equal to V by R. See this one. Under series resonance, the net impedance is minimum and the current is maximum, and hence it is an acceptor circuit. For series resonance, total voltage appears across the resistors only, hence it is called voltage amplification circuit. This is also very important. Voltage amplification circuit. Series resonance phenomenon is used in the design of receivers, antennas, and in communication engineers we are considering that. Right? These are the applications you can take it. Like that we can take the parallel resonance, where we are considering that parallel resonance. See this. For RLC series parallel circuit, same. Series circuit, how much you got the omega naught? Same. Right? Because the resistive nature. And under parallel resonance, net admittance is minimum. Admittance is directly proportional to current, that's why current is also minimum. That's why these are circuits are nothing but the resistor circuits. And for parallel resonance, the total current passing through the resistor only, and hence this is the current amplification factor. Their voltage amplification circuit. Parallel resonance which are using induction heating system and RF amplifiers, radio frequency amplifiers, we are utilizing or we are using. These are the applications. Both RLC series and parallel resonance circuits are used in tuning circuits. Everywhere we are seeing this one, right? Filter circuits. In filters also we are using that now. And while coming to that here, parallel resonance, tank circuit here, this is very important. For tank circuit, you know that for tank circuit, under tank circuits, RL and C are connected in parallel. This is the first tank circuit. Ideal tank circuit means resistance value is equal to 0, pure inductor. Pure inductor and ideal capacitor. Ideal inductor, ideal capacitor, we have to take it. That's why we are getting omega naught equal to 1 by root LC. There 1 by RC under root 1 by root LC, 1 by LC minus R by L whole square. And this is the question which was given in previous PSUs. Remember this one. The dynamic impedance. Dynamic impedance for the various circuit. Impedance offered by the network to the source under resonance condition is called dynamic impedance. Usually we are considering the resistive nature circuits. And series RLC, parallel RLC, tank circuit, ideal tank circuit. See this. Series RLC dynamic resistance is R. This one is R. Parallel also R. And while coming to this one, L by RC, here it is infinity. Why? Because there is no resistance. There is no resistance here, right? Instead of resistance here, what it is, open circuit is there. That's why R is equal to infinity, dynamic resistance for this one. But for this you can define, that is what L by RC, right? This is about the resonance part here. This is about the resonance part. Now while coming to that, the next one is bandwidth and quality factor. How you define that bandwidth? Bandwidth is nothing but what it represents the range of frequencies for which power level in the signal is at least half of the maximum power. You know that half power frequencies. Half power frequencies are 3 dB frequencies. 3 dB frequencies we are considering. For series circuit, current response. For parallel circuit, voltage response. Right? And while coming to that, for low frequencies, resonant frequency is the geometric mean. For high frequencies, arithmetic mean. Low frequencies, 3 dB frequencies. 3 dB frequencies means what? Low frequencies, F0 is equal to F1, under root F1 and F2. Guys, this is we are using. In electrical circuit, this is the only we are using. Why? Because in electrical circuit, low frequency. High frequency means F0 equal to F1 plus F2 by 2. In electronic circuits, you may take that one. But in electrical circuits, compulsory, we are utilizing that low frequency. If you consider that AC, it may have either 50 Hz or 60 Hz, it is a low frequency. That's why the condition of here, the relation of resonant frequency and 3 dB frequencies is what? F0 is equal to under root F1, F2. Is it right? while coming to this one, for this high frequencies, suppose if we are considering that high frequencies, see this one, high frequencies, we can take it, f naught is equal to f1 plus f2, arithmetic mean, middle you will get it according to the current waveform. I think once you recall the current waveform, then definitely you will get it. Current waveform, I think you are having that current waveform. This is the current waveform. I will get it in the middle, f0, f1 and f2. I think you can recall this one. Now the next factor, one of the important factor is the Q factor. For series circuit, Q factor is called voltage magnification factor. For parallel circuit, Q factor is the current magnification factor. First of all, what is the Q factor here? Q factor means what? It is the ratio between the two similar quantities is the factor. But quality factor is what? How you define the quality factor? Quality factor, if you want to define, just I will give the one simple example. Suppose once you start a good business, after 1 year if you want to define the quality factor of your business, what you can take it? How much money we have invested, how much money we earned. Money earned by money spent is the Q factor, not money spent by money earned. Money earned by money spent. Why? Because finally we are having in our hands only earnings, right? Based on that, how much energy stored by either inductor or capacitor by energy dissipated per cycle is nothing but the quality factor with the multiplication factor is there. That is the quality factor for series circuits, quality factor is called voltage magnification factor. Voltage is different. In terms of that we can define, right? And now if you take that for series and parallel circuit, the quality factor, these formulas are very important here. The quality factor for series circuit, Q factor is equal to what? XL by R, omega L by R, and this we can take it for RLC series circuit. Series circuit, RL series circuit is this one. RLC series circuit means either XL or XC by R. Why? Because 1 by omega CR. Omega naught, why I am considering omega naught for RLC series circuit? Because for RLC series circuit, as per the maximum energy stored where under resonance. That is why the operating frequency we should consider under resonance. This is the quality factor either XL or XC, since both are same under resonance. And we can also take that the quality factor for series circuit in terms of circuit constants, which are R, LC. I can take it omega naught is equal to 1 by root LC. Na? If you take 1 by root LC, finally we are getting 1 by R times of under root, what I can take it? L by C. This is the series circuit quality factor. And for parallel circuit, you need not remember, directly you can take it as a reverse. Reverse of this one is under parallel circuit. Suppose if you take that reverse, how you are considering that? Here, for parallel circuit, QP is equal to here R by XL. I can take it here R by XL is equal to R by XC, nothing but R by omega naught L is equal to omega naught CR, and QP I can take it, this is also reverse, R times of under root C by L, R times of under root C by L we can take it, right? And while coming to that, the tank circuit, for tank circuit the dynamic resistance here R naught is equal to R into under root 1 plus Q square. This formula you can remember that, but this is for gate point of view it is important, right? Now let me consider that some of the examples under this one. This is about the AC circuit analysis. After this we will discuss some of the examples on AC circuit analysis. Now time is yours. You need to answer the questions. Tell me this. Tell me this here. Are you there? Now time is yours. You need to answer the question. Tell me this. Any one of you? The question is the voltage V and current I of a device are V is equal to 100 sin 377t, I is equal to 10 sin 377t plus 30 degrees. The power P indicated by the wattmeter will be. Tell me this. Yes. Bhushan Sai was given correct answer. Wattmeter will read what? Wattmeter will read active power. P active is equal to VI cos phi. Very simple. I can take it. That is what? V is equal to what? RMS value here by root 2 you can take it. 10 by root 2 cos 30. Here 500 into root 3 by 2. 250 into root 3. Nothing but 433 you can take it. 250 into root 3 is not 500. 250 into root 3. Root 3 is what? 1.73. You need not go for calculations for this one. You need not go for calculator for this. Directly 250 into root 3. 1.732. It is less than 500 first of all. Less than 500 means which is D. Directly you can take it. You need not go for any calculator. Are you getting? Guys, is it okay? Yes or no? Very simple. These type of questions you can expect. Let me consider the next example. Is it okay for you? Very good, very good. Sunil Kumar also given correct answer. Excellent. Right. The question, next question. See this. Next question. A series resonant circuit implies. Tell me that. Which is the correct option? Zero power factor and maximum current. These are the previous PSUs here. Don't think that very simple questions. These type of questions you will provide here. Because in the examination, your presence of mind is very important. Right? Zero power factor and maximum current, unity power factor and maximum current, unity power factor and minimum current, zero power factor and minimum current. Tell me this. Anyone? Anyone? Again. Right, very good. B is the correct option. Series resonant circuit here. Resonant means what? It is UPF. Current is what? Maximum. This is the waveform you will get it at resonant frequency F0 I max. Is it right? This is the very simple. I think you know that. Now next one. See this. Right, good example here. Tell me this. Now time is for you. A current I is equal to 10 plus 10 sin t amperes is passed through moving iron type ammeter. Its reading will be. Tell me that. I am waiting for you. Which is the correct option? Please do this. Yeah, very good. This is actually the question is given current signal is it is a combination of DC and AC here. This is DC and this is AC. You are having a formula for this one. If it is DC, AC is there. Then using that formula you can do it. For DC and AC signals, let me consider that. Here, suppose V of t is equal to V0 plus V1 sin omega 1t plus V2 sin omega 2t plus so on V1 dash cos omega 1 dash t, V2 dash cos omega 2 dash t, cos omega 2 dash t plus so on. For this one, average value is V average value how much? V naught only. But guys, remember in this one, so many students you may not have that idea. This omega 1, omega 2, here omega 1, omega 1 dash. For sine and cosine, the frequency term or the frequency values should not be repeated. You need to be ensure that. Once you ensure that, you can take it, this formula V average and Vrms is equal to under root V naught square plus 1 by 2 times of V1 square plus V2 square, so on V1 dash square plus V2 dash square, different. Now here we need that here Vrms. Why Vrms we need that? You may get a doubt, sir. That is what? Here he wants that moving iron type is, usually it will read that RMS value. It will read that RMS value. That's why the RMS value I can take it here under root 10 square plus 1 by 2 times of 10 square, which is under root 150 amperes. Under root 150. Suppose if we ask that moving coil type, PMMC type, here average value will be equal to only 10, you will get it. First one, right? Here this we are getting under root 150. Let me take the next example. Got it? Good one here. Tell me. Tell me this. Any one of you? In an RLC circuit, susceptance is equal to very good question here. Anyone? A is the wrong option given. Remember this is RLC circuit. He didn't mention that whether it is series circuit or parallel circuit. Then another time what you may think, that is decided by the given options. Here the options are given. Suppose if it is parallel circuit, directly may give B. RLC series circuit or RLC parallel circuit, if it is parallel circuit is given B. But if it is given in terms of R's, X, Z means this represents series circuit. Remember that. For series circuit, RLC series circuit, for RLC series circuit, you should realize that. You should realize that based on the values are given in the options. Now, the total impedance is nothing but what? Impedance is Z is equal to R plus J times of XL minus XC. Or I can take it R plus JX. But he wants the susceptance. What is the susceptance? It is inverse of reactance. You know that. This is inverse of reactance. But for this circuit, susceptance is RLC series circuit. You should consider that here the susceptance means here we need to consider susceptance can be defined for admittance only. Susceptance can be defined for admittance. Under the total admittance, we should consider that what it is? The imaginary part. Now, the admittance for this one is equal to, in terms of impedance, 1 by Z. Now, the admittance for this one, if you want to take from this impedance, I will consider that 1 plus R plus JX. Then you can take it here. You need to rationalize that. With this you can take it r minus jx. From this you are getting that r minus jx by z square, r square plus xl square. Na? Yes or no? Now usually we are considering for series circuit here admittance minus jb or whatever it is. According to the options you can take it. Once you compare that, what is the real part in the admittance? Admittance can be defined here r by z square minus j into x by z square. Which is the real part, which is the imaginary part here? I can take it, the real part is nothing but the conductance, imaginary part is referred as a susceptance. This is called conductance. Remember this, you cannot take directly. This is called susceptance. Getting? That's why, which is the correct option? Option D is the correct one. You got it? Is it clear? Is it clear? D is the correct option. Is it clear, guys? Very good. Shall we move to the next example? Yes or no? Yes. Very good. This you can see. It's very simple. From the basics you can take it. See this, I am not giving here gate questions. I am giving that PSUs questions because we are discussing about the PSUs. Once if you forget the fundamentals, definitely if you follow that all the gate questions, if you are forgetting the fundamentals, then definitely it will be very much difficult to answer the question in the PSUs, public sector units, directly 1 mark, 1 minute. Sometimes you may answer within half minute also. Tell me this. Next one. Tell me, guys. Which is the correct option? Right, this is what RLC parallel circuit. Very good. Given correct answer. That is what, whatever the summary points I have given the directly. This is RLC parallel circuit. For an RLC parallel circuit, resultant current I is equal to under root IR square IC minus IL whole square. IC minus IL whole square, because IC is always leads. Voltage is same na. That's why usually if we take this, how we are getting this, we can also take that how we are by vector diagram. If we take this is voltage same na. That's why I will take that voltage is same. Then you can take it, this is IR and this is IC. This is IL. This is plus JIC. This is minus JIL. Now 180 degrees phase shift. Once you add it, minus JIL plus JIC. That's why this is the formula you will get it. Finally, I can take that under root IR square. R is here. 3 square plus 5 minus 1 whole square, which is equal to 5 amperes. 3 square plus 4 square. 3 square plus 4 square. Is it clear? It's very simple. And 3 square plus 4 square, here guys I will provide some of the very, you need to remember that good content I can give that here for this one. In PSUs you need not go for any calculators. This will be useful for power system, even for power system and machines also. Now two angles you need to remember that. First one is phi 1 is equal to 36.86 degrees and phi 2 is equal to 53.14 degrees. You can add it these two, you will get that resultant angle is 90 degrees. Now one is less angle, other is more angle. Now I want to take that here. The power factors you can easily define that phi 2, this is the phi 1. Some of the standard figures here. Usually in power system and electrical machines, we may take that the power factors are in two types. Number one is as per the figures 0.6, 0.8. Now 0.6 means what? It is 3 by 5. Cos means what? Power factor is equal to cos, na? 3 by 5. Then under that instant this is 4. Are you getting? Now once you are getting that power factor is equal to 0.6, usually 0.6, 0.4 you are getting, 0.8 you are getting, which is more, 0.8 is more. More is having less angle because cos phi value is varies, remember this, cos phi value is varies, this is 1 to 0, where when phi is not degrees, this is here phi 0 degrees to 90 degrees, 0 degrees to 90 degrees, yes or no? That is why this is the less angle, we need to concentrate on the less angle. Now here we can take it, first one is what? This is less angle. Now phi 1 is 0.6 means more angle, you will get it. 0.6 means more angle, that is why this is 4 and this we can take it. Phi 2 is 3 by 5 and this is 4. Are you getting? Now that I can take it cos phi 1 is equal to less angle more 0.8, 4 by 5, cos phi 2 0.6. These are the usually we are using that under power factors, right? Now not only this, we can also take that here, these one are here. Sometimes you may provide that it is, if you multiply with 2, 10 also. Now this is 6 and this is 8, this is 10. With the loads, conversion of polar to rectangular, suppose 3 plus J4 is there. What we are getting here, 3 plus J4 is there. This is 6, nothing but what? Here I can take it 3 plus J4 or 4 real part plus J3. What is the real part? Magnitude is 5 and angle is less angle or more angle? This is less angle. Why? Because power factor is more. Now this same way we can take it 8, suppose minus also sometimes you can take it. 10 at an angle minus 36.86 degrees. Remember this, right? Now like this, here I can take it, we will consider here the Z2 value, this is Z1 value, Z2 value, here 3 minus 4J, polar form is what? I can take it 5 at an angle minus 53.14. Guys remember here, more imaginary part, more angle, less imaginary part, less angle. Like that here, 6 plus J8 is there, magnitude only change and angle is same. These you have to remember, conversion of polar to rectangular, rectangular to polar. Don't go for the calculator for this type of figures, right? Let me consider the next example. Right, tell me this. These are also very simple here, all simple questions. Previous questions. This is the resistor. Tell me the answer. The voltage across the various elements are marked as shown in figure given below. The input voltage is, tell me this. Right, very good, very simple. This is under root VR square, V is equal to under root VR square plus VL minus VC whole square. This you can get it under root 3 square plus 14 minus 10 whole square, which is equal to what? 5 volts you will get it. It's very simple, right? This was given in the previous examination. Right. How much this? Two sinusoidal equations are given as, then what is that? What is this? Tell me. Which is the correct option? Whenever, if these type of questions are there, try to develop the vector diagram. Now, by taking that vector diagram here, this is 0 is reference. E1 is what? 45 degrees, na? Pi by 4. Pi by 4 means what? This is 45 plus 45. This is minus 30. Now, once you consider that plus 45, this is E1 and minus 30, E2. Minus means this symbol represents. Don't take that minus there. If you take minus, you may get some confusion. With this, the direction will refer whether it is positive or negative. Whether it is positive or negative. Now, from this, the phase displacement is equal to what? The phase displacement in this one is, PSU's questions will be like this, 30 plus, what it is? 45. It is 75 here. Option A is the correct one. Okay? Very good, very good. Excellent. Yeah, all are previous examination questions. Right. Good example. This is good example here. I'm providing here the options as A. You do this. This is related with the magnetic circuits. Come on, guys. Tell me the answer. Come on, tell me. Tell me. Direct expression here. Direct expression. Two coils with self inductances 1 Henry and 2 Henry having a mutual inductance of 1 Henry between them carry the currents 2 amperes and root 2 amperes respectively. The total energy stored by the field in joules. Anyone? Anyone? One expression you are having, right? Let us take that here. The energy stored for a coupled circuit, I have given that half L1 I1 square plus half L2 I2 square and plus or minus M into I1 and I2. That is the formula. With that formula, you can take it directly. What we are getting that? For a coupled circuit, W is equal to half L1 I1 square plus half L2 I2 square plus here, there is no 2, here we are having M L1 L2 according to the formula. That formula we have taken. Now, according to that 1 by 2, 2 into 1 Henry or 2 Henries, it was given. 1 Henry and 2 Henry, 2 amperes and root 2 amperes. 1 Henry, first one is what? 1 Henry and the second one is 2 amperes and second one is 2 Henry and root 2 amperes plus M 1 Henry and 2 into root 2. Yes or no? This is what we are getting, that 2 plus 2 plus 2 root 2. Now 2 times of here 4 plus 2 root 2, 2 times of 2 plus root 2 joules. This is the energy stored by the coupled circuit. All are positives given. That's why I have taken one is both are entering or leaving at that. This is the formula we have to take it. Actually plus or minus is there. From that you will get it. Is it okay? Now this is the good example here. Is it okay? Right. Option B na? Which option? Right. Option B is the correct one. Right. Let me consider the next example. See that? In the circuit shown in figure given, instantaneous I of t under steady state is. Here actually question was, this is the 5 volts DC. This is the 5 volts DC given and this is the AC given. You just, here resistance is given, 1 farad is given. Now this is AC DC here. How we need to take it? We should convert, we need to use what? Superposition theorem na? By SPT, by superposition theorem we can take it. First if we take the DC, for DC inductor is what? Short circuit, capacitor is open circuit. Now on the time, what is the value of I? 0 no? There is no current is passing through that. Nothing but the current is only with the effect of AC. Whenever AC is there, what is the omega? Omega is what? Omega we can take it as here. Omega I can take it. Right. Omega we can consider sin omega t. This is what V of t is equal to Vm sin omega t. Omega is equal to 1. This is what J2. This is what minus J. Resultant is what? 1. 45 degrees you will get it. 1 plus J you will get it. Now final answer is what? Final answer can you take like this? By SPT, V of t, sorry, I of t is equal to, are you getting? By SPT, I of t is equal to, you will get final answer 0 plus 10 by root 2 sin omega t or t minus 45 degrees, minus 45 degrees. See that? How we are getting means the detailed solution I will provide. For DC, first for DC, inductor is short circuit and capacitor is open circuit. Yes or no? Now under that instant, this is one source at a time. Na? This is the circuit, you will get it. Now I1 value is equal to 0 for 5 volts. Now for AC, V of t, omega is equal to 1 radians per second. Now ZL is equal to J omega L, which is J into 1 into 2, which is J2. And next one is what? ZC is equal to 1 by J omega C. 1 by J into 1 into 1 minus J, 1 by J ohms. Now from that the network, this is TC circuit is short circuit, AC circuit we are getting sin T. Now resistor is 1, inductor, capacitor, because network is operating with the finite frequency, this is J2 and minus J. Finally, I can take it this I2 is equal to, I can define directly V of t, nothing but what? I can take it 10 sin t by what it is? 1 plus J2 minus J with this 10 sin t by 1 plus J. From this I can take it 10 by root 2 at an angle 45. Now sin t minus 45 Finally, by SPT, by superposition theorem, by SPT, I is equal to I1 plus I2, finally 7.07 sin t minus 45 degrees. This is the final answer. Getting? Clear? Is it okay? Right. See that? Right. This is the good example here. Bandwidth A, B, C, D. What is the bandwidth of this one? How you define the bandwidth? Tell me the question. Tell me the answer for this one. The bandwidth of AC series circuit consisting of RLC. Tell me. Good one. Anyone? No. Answer is not correct. Someone is saying C. C is not correct. Bandwidth, first of all. Directly you can say that. Bandwidth means here, you know that. What is the definition of bandwidth? Bandwidth is equal to what it is? Resonant frequency by quality factor. RLC series circuit. You tell me now. Now you can say. Just you replace the quality factor here. Very simple. For RLC series circuit. Now you will get the answer. Tell me. Anyone? Tell me here. Replace quality factor. It's very simple. Omega naught by, that's why omega naught L by R. Just now I have given, this is R by L. Option B. Simple, na? Is it clear? These type of questions you may expect. Excellent. Now, this you can say, form factor of an alternating wave. Tell me this. Option. Tell me. This was given in the previous examination. Option. RMS value by average value. C. Very good. Phase difference is already 75, already we have taken. Right, give me this answer. The phase difference between the following voltage and current. These also 50, option B, plus 30 minus. Right, this is very important here. Now tell me this answer. Tell me the answer. This is very important. A geyser is operated from 230 volts, so 50 cycles per second means the frequency of the instantaneous power, very good, consumed by the geyser. Instantaneous power. Instantaneous power equation just now I have given, what it is? Vi cos phi RMS value minus or plus, or minus or plus, whatever it is, Vi cos, how much? 2 omega t plus phi. Then tell me example, what is the question for this one? A geyser is operated from 230 volts 50 cycles per second means the frequency of instantaneous power. If you take that a geyser is operating with V of t is equal to Vm sin omega t. This is the related instantaneous power. Tell me that operating frequency of instantaneous power. Ah, very good. He was given 4, but it is a B is correct answer here. If the operating frequency of a voltage is equal to given as omega, this is going to be what? 2 omega. If it is 50, then it should be 2 into 50, which is equal to 100 cycles per second. 100 cycles per second. C by S means cycles per second. Got it? Cycles per second. Clear? Right. Tell me this. This you can say D. What it is? V is equal to under root VR square plus VL square. These are all previous year. 3 square plus 4 square. It's very simple. Everybody can say. Whatever the discussion we made, with that you can say. I need not go for more discussion for this one, right? This you can say. See the question. In single phase series RL circuit fed by voltage source, the resistance and reactance values are 4 ohms each. In this circuit, this one also you can say here directly, need not go for any calculations. Tell me for this. Come on. Answer. Right. Current lags voltage by an angle 45 because Z is equal to R plus JXL na? 4 plus J4. Very good. Excellent. Right. An electric iron is rated at 230 volts, 400 watts, 58. The voltage rating 230 volts refer to what? Very simple. Peak to peak value. Nothing but what? Maximum value. It's very simple. See that how the simple, this is what value? Rated at means it is not peak value, this is the RMS value. The voltage rating, electric iron is rated. 230 volts is RMS value compulsory. No doubt. Peak to peak value is different. Right? It's RMS value, no doubt. Circuit values are always RMS values. Now see this. In an RL series circuit, the phase difference between the applied voltage and the circuit current will increase. In an RL series circuit, the phase difference between the applied voltage and circuit current will increase. When it will increase? Phase angle increase means XL value should be increased. What is the phase angle for? For RL series circuit, are you getting? For RL series circuit, phase angle when increase? Phase angle is what? Impedance angle. R plus JXL. According to the options, you have to take it here. According to the options, phase angle phi is equal to what? Tan inverse XL by R. Phi value when you increase tan inverse. Tan value when it will increase? If 0 to infinity. That's why XL value is increasing from 0 to infinity. If you take that XL value is increasing from 0 to infinity, then definitely phi value is also increases. Phi value will increase. XL value is increasing, phi value, because tan theta is increasing from 0 to infinity. That is why, which one? Even the supply frequency will decrease, XL value will decrease, because XL is what? Omega L. Getting? Is it clear? Very good. All right, here, good example. Tell me this. Now your turn. Come on. Now this is your turn. You can do it. First of all, based on current you can define here. Based on current you can define, and first you need to estimate that complex power. First, based on this current angle is negative, that means what? Current lacks voltage, inductive nature here. With this I can take it. Voltage is leading, whatever it is here. Voltage is leading some angle. If it is, this is 0 degrees, this is phi 1 and this is phi 2. Current is lagging, no doubt in that. That is why with this I can cancel these two. Now next one is, you know that S is equal to what? VI complex. Already you know that. Complex power is VI complex. VI complex means what? 200 plus J 40 complex. You should consider 3 minus J 10 complex, nothing but 200 plus J 40 3 plus J 10. With this real part 6000 minus 400 5600. Now 2000 plus 1200 3200 plus only you are getting. This is P and this is Q, this is watts and this is VAR. Option B is the correct one. Are you getting? 5600 and 3000. Very good, very good, very good. Next one. Right, a series RLC circuit Q factor is given by. It's a very simple, no? Series. This is the correct option. See that how the questions in the previous examination, right? These are the questions, you can take it. Right, these are the questions. Now today's session, I think it is, I hope it is very much benefited for you regarding the syllabus wise and some of the questions, how the standard of the questions in PSUs, especially public sector units, right? This is the way how we can answer the questions directly, right? Take the enrollment in AC Engineering Academy to get that real content, quality content in AC Engineering Academy. Definitely you will get it. I will give the guarantee for you. Believe me, believe us. And if you want to crack the job in any PSUs, definitely you will get it. Here we are promising that definitely you will get the content or concepts wise. Each and every concept you will get it. With that you can crack any type of PSUs, any type of PSUs. Okay, all the best. Thank you. Good night.